Hey everyone, welcome back to this series of building AI agent from scratch. I am Nitin. So in the last two episodes, we have learned about the logging in production for AI agent. But now, before moving towards the more advanced topics of AI agent workflow, I just want to slightly go slow and focus on very important topic of this thing is the prompt because prompt is a very basic fundamental block and very important concept to understand and explore to get the very basic ideas about the things of how LLM is behaving and why it's behaving like that. So you already use the prompt engineering, or maybe you are using in maybe daily life, chat GPT, Gemini, Claude, everything. But how we are going to use this prompt engineering with the already sort of well-researched techniques that people are using, like chain of thoughts, tree of thoughts, all these things. So in this episode, next 20 to 25 minutes or 30 minutes, we are going to explore all these basic techniques from asking a question in a very vague language from LLM to going in very structured question answering with LLM, and how we are going towards more structured answers that we are planning to get more consistent answer and understand how LLM is behaving after I ask the question. So in just a couple of minutes, you will understand all the basic foundations of prompt engineering, not just that they hey, just write the document and all, but the basic ideas or sort of a techniques how like techniques like chain of thought, few sort prompting, and zero sort prompting. So all these technique, all this term will not be buzzword for you anymore. I will explain one by one in a proper flow to get an intuition, an idea, and how this thing work in a real time code. To show you, and then you will be more confident. So by end of this episode, you will have an idea. You can say, okay, I know very well how this prompt engineering techniques work. So yeah, before going to let's understand the concepts. So before deep diving into all the code stuff, let's just understand what sort of prompting techniques are there. The very first technique is zero sort prompting. Like we just ask the question without doing anything, without giving lot of instruction or lot of the examples. So and very when you just given when you just given couple of example that called a few sort prompting, and we have the chain of thought, zero sort. I will explain one by one, but let's understand the very first thing is the zero sort and few sort prompting. What is the difference? So we if we ask this question like classify this review, great product, love it, and just something LLM say it's a positive or negative. That's a simple zero sort. You are not giving any sort of a glimpse of your examples to the LLM. You're just asking blindly, okay, what is this? And if you give in a counterpart, if you give couple of examples like, okay, I have this review, the review is positive, and the is this for negative, label is negative, and the label is neutral. Now tell me what is the label for this my example. That technique called the few sort prompting. You give just two three example and then ask the next your data point like what is the label for this part. So this is a very basic thing. Now let's understand by how we implement this thing into the code. So before understanding, these are the 9 techniques I'm going to cover in this episode. So let's first start with the importing my operating the OS and JSON. So before we run the code and LLM call, we need the OpenAI API key that we are using in this series. Mostly, users need to save your OpenAI series, and then you create the client as we are doing in the last all the episodes mostly. So now we have our model is ready. We are using GPT-4 Mini because pretty cheap, and we need to run a lot of examples. So and it's faster. So yeah. So now we define our first the LLM call. So let's define our LLM call. We say let's ask and ask. We will pass our prompt. So prompt is the thing you ask the question. You ask something from your model, and we say okay, we have system none as of now, and let's define the temperature. Temperature is the thing is defined by how much randomness or the creativity you are giving your model. So if we set the temperature is zero, that means I don't want my LLM to be creative. I want more sort of a consistent answer. So and response format. I am not defining any format, so it's a none. I will explain all these things in just couple of couple of minutes. Just hold a bit. Now, this is the message we use. So messages, let's create a list. And if we have some message, because I'm defining this thing that will give you idea. If messages are message, if system, how we are, okay, if system, yeah, we need to check the system part. So if system prompt is there, and then we will append messages dot append our the role, because we are going to use the role. So a role tech role sort role is a system. We are passing the prompt is like that. So role is the system, and my role will be the what is the question I'm asking will be the content. We already saw this thing into our previous series and in the starting episode, and this will is the how we define this content. This is my content. My content is the sort of a I'm asking. So that okay. The system. If I am getting something as a system, so what is the role? System is the content I'm defining. Okay. Now if I define this thing, my system message is there. Now I need to append message dot append. Append is the sort of a again one more dictionary. The role. The question I'm asking is will be go from the user. So role is user, and is my message is my message is the message I am asking. The message is the input I have from the top. Okay. And now if I have this part, okay, let's, okay, no, here will be my content, sorry. Here the message user, and because I need to pass this as a prompt, sorry, my mistake, my bad, because here message will be nothing, the whatever I'm getting from the prompt. Okay, now I have this prompt ready, the message is ready, message will go to my system. Now start my arguments. I'm defining these things very first time. So just defining this as a dictionary of my argument. So what is the temperature I'm looking for? What is the model name and the message? This is the argument. Now, if I have the response format, so I will add this as into my the response format. I will pass this as argument as a response format. It will be my response format. Otherwise, if it's not available, that can be the case. Yeah. If it's there, I'm handling all the cases. Now is main part the response, how I'm going to call. So my client that I created on the top. So client dot chat dot completion dot create, and then all the argument I'm getting. Okay, and now just return. So return. I'm returning my response, and the response will response dot choices. That's how we already saw this thing, how we get value out of my response, and then message and then content. Simple. I will return this part. Okay. Now by this thing, my one sort of a how I'm going to ask the question from LLM is defined pretty well. Now, what is the my zero prompting? So let's understand the zero prompting. If I am asking, my question is, what is the capital of France? Let's say my question is, what is the capital of France? If it's a simple question, and I'm asking from my, let's say, result is, I'm asking this LLM, this is my question. If I pass this thing as a question, what output I am getting? And let's just print it. The capital of France is Paris. This is the zero prompt. Now let's understand the few prompts. So how the few prompts works. Now few prompts is simple. If I'm asking, or maybe let's understand one more example. This is actually like you were saying, how can I ask the more prompt on this thing? So if you ask a simple question by if a shirt costs $25 and it's 20% sale and you have $5 coupon, what you will pay? What do you pay? So let's see this thing, how it's working. So what is the result I'm getting? You ask this question. I can print it. You are seeing to find out how much you need to pay. That's how this is breaking down step by step. And it's saying the final one you need to pay the $15. Okay. That's how it's going step by step. Simple factual question you can ask from this thing, classification, translation, and most of the time, this is very simple calculation, it's failing, but it will fail. Uh, it can also fail miserably when you ask a lot of complex mathematics questions. So I would say if you are looking for more complex logic mathematics, don't go for zero sort. Wait for the more new techniques. So now how can I pass the couple of example to my prompt? So let's say if I define my prompt like classify the sentiment of my each review. I have this review. The product is amazing. I love it, and sentiment is positive. The terrific quality broke after one day, negative. Again, I have one review. It's okay, nothing is special, but works fine. Sentiment is neutral. Now I have this, my example that I'm looking out of it is the delivery was late, but the product exceeded my expectation. And I am looking the sentiment of this of my sentiment of my sentence. How I'm going to ask it? So the thing is, already I know I have this function defined. So I'll ask this prompt to my ask question and check what is my final output. So let's run it. Okay, I got the positive because it's a product exceeded my expectation. So clearly it's a positive. That's how it works in a few prompt settings. So you just gave a couple of a sort of examples to your system and ask. Let's see one more example to get more idea about it. So we have this thing, a input. John paid $150 for the repair. So we want to extract the name and amount for each sentence. So John paid $150 for the repair. Sarah received a refund of 42.5 cents. And all these things I want output in this format. Name John, amount this, name Sarah, amount this. Now I have this company charge Mike $89 for shipping. I want to ask that I want to extract the name and the amount. So same, I will run my same thing. I will pass this information to my. So it's more like a giving LLM an idea. Like I have this problem and I'm finding out answer by this way. Now you have this. Now you have the same pattern. Find out the answer. Okay, so this is the sort of a way of giving LLM how I am finding the answer, how I'm looking this question as an answer to narrate. This is the way you need to look from my look my question in this perspective. Okay, without going here and there or your internal knowledge. That's how I'm looking out of it. So it's a technique called few prompting. It's very good, very efficient, works pretty well when you need to explain your complex task to your sort of the model. Even if it will work very well when classification is good example, but you can do sort of an extraction when let's say you have a very complex information like for medical domain and financial domain, and you want to extract a lot of information out of it, like transaction or the maybe some discussion. So textual data is very complex to understand and extract. In those cases, you just give the example how you are extracting the information, and just that's how LLM can understand, and LLM give the extraction output pretty well. And even the formatting, you can do the formatting when the data is complex. You are looking for formatting from using LLM. That's the one use case because you give example. Okay, this is the data I am formatting in this way. This is the data I am formatting in this way. Now this is the data you give me the formatted answer. Same a lot of the pattern based task typically. But you need sort of a you gave a variety of 2 3 example. If the variation is huge, then it can be issue. But yeah, for good variation, it covered by 2 3 examples usually, and it's worked pretty well. Now you got an idea by a very simple task, very simple things. Now you want to ask a very complex mathematical calculation from the model, and it typically give you one line answer. But you want to understand how it's going step by step, how it's doing the mathematical calculation internally. So for this part, we want to understand how my model is behaving internally. So for each thought, how is doing. Let's say if I'm asking the very simple question. uh, this is my question. A store has a 45 apple. They sell 18 in the morning, receive a shipment of 30, then sell it 22 in the afternoon. Now, how much apple they are left? So it need to understand like, okay, what happened this and there's the addition, there is a deletion, there is addition. Now, what is my final value? So there is a multiple steps and there are multiple thoughts. So we need to understand what are the thought process my LLM is going through. To understand this part, we use a very basic technique as a chain of thought. So for this sort of question, how you understand how is my LLM is working? So let's just ask this question. You have this thing, and if you ask simple part and print this thing, it will give me sort of a without chain of thought. This will be the part. I have not explicitly asked like give me the reasoning step by step and all. It's saying from the internal knowledge, start with the initial number of apple 45, subtract the number sold in the morning. But now I want to give sort of a prompt from my end. Like I want the step by step reasoning. So how I'm going to give it? So let's add the prompt of the reasoning part. So I gave the reasoning as a so your reasoning step by step before giving the final answer. This is the part I have added. And now if I just ask this question from my LLM. Let's say I pass this prompt by adding my question, and let's say with COT, how is that behaving? And now it will show me, it will break down. Instead, here it was showing, okay, I did this, but now it will show. Let's break down the problem step by step. Here it doesn't mention like this. It can say follow step. Initial number was initial number of apples. Apple sold in the morning, and then apple in the morning sell after this. Apple received with a shipment. Here it was not working like this. It was saying add the number to the apple received in pair, subtract the number. But now it's giving more precise steps like apple received in shipment, apple sold in the afternoon, and after this calculation, let's say now let's summarize the calculation. Start 45 apple after this, after receiving shipment. You got the final number as a 35. That is the exact number. That's the right number. But now you know the idea how is my LLM is going step by step. Very good, very sort of a good learning and good understanding how LLM think internally. Let's give more a complex example. So I have this example ready. I'll give you I'll fire to my LLM. So let's see, understand. So solve each problem step by step. I have this question: if bakery bakes 120 keys, sell 25 45 in the morning, 24 30 more, sell 30. How many left? Let me think step by step. So it's a chain of thought with sort of few prompts. So it's saying, let me think step by step how you need to think the answer. We combined my last technique as a chain of thought with the few thought. So I gave again how you need to thought it, how you are going to think about my problem solving. And then I asked the same question. Now let's understand the thing. So how it will behave. So it gave me the answer. Again, the same, 35 apple. But now it doesn't go in that sort of detailing. I gave the answer and I mentioned how you need to go with it. Step one, step two, step three, step four, and final answer. Instead of by themselves, the initial number of apple and all these things, it's just giving, it is going in the direction how I defined in my prompt. Let's say I don't have any sort of a way I'm looking out of it. So can I go zero prompt, zero sort? So this is the zero sort. I'm saying if you have a three boxes containing four bags or that's number, but without a this can be let's first understand how this will answer without any prompt. So I asked this question: if you have a three boxes, each containing four bags, and each bag has a five marble, how many marble do you left? It calculated Like I have this one box is containing 4 bags, and then three boxes, total bag and multiply, and then it says 60. But now let's go into more of a chain of thought thing. So how can I do it? I just define it. Let's think step by step. Very simple one line, but how powerful is that? So it went into more granularity and give me, okay, zero sort of thought. And that's how to find a total number of marbles, we can break down the step by step, determine the number of bags in one box. Each box contains 4 bags. Determine the number of bags in all boxes. Then it says since there are 3 boxes and total number of bags is 3 boxes into 4 times into 12. Okay. Now I got the total boxes. Determine the number of marble in one bag, each bag. So each bag contains 4 marble and then it's multiply and then it says 60. So now it's a zero sort chain of thought. I don't give any example. This is pretty powerful. This work very well for the complex example. So let's get into more complex examples. So is the following statement true or false? All roses are flower. Some flowers are fade quickly, but therefore rose fade quickly. So I ask this question very plain. Let's understand. It's more like how it can do the logical reasoning. The promise do not guarantee the truth of conclusion. Therefore, the statement is false. Okay. Now, can I think how why it's making the conclusion in a chain of thought manner? Let's do it. Let's think step by step and give me the answer. So I know correct is the false because it gave me result. Because I know it doesn't mean that's totally true for everything. So it gave me final answer. The statement is the false by analyzing, understanding the premises, analyzing conclusion, logical reasoning, and conclusion. Going pretty well. How the step-by-step thought process is staying with me. Now we understood chain of thoughts. How the chaining is going in the thoughts level. We can have one thought and multiple reasoning perspective. Let's understand that part. We call it a tree of thought. Very famous technique. So we use in this LLM prompting. Let's understand how the tree of thought works. So tree of thought is nothing. Let's go to our slides and understand the tree of thought. So we saw the chain of thought, how you ask the question and sort of easy upgrade. Now tree of thought is something explore multiple reasoning path. So you can have one question and can multiple paths of solving the question, and then you choose the best out of it at the end. So that's how a tree. That there is a re- one node, and then can be different branches, and then we find out the best answer at the leaf. So consider 3 approaches, solve the problem, and find out the best approach at the end. Okay, you can explore the 5 approaches or 10 approaches, but it will take more time to if you give more approaches. But let's stick with less approaches and understand. Our idea is to understand the approaches. So we give first the prompt, very basic prompt. So in tree of thought, this is the prompting. Question is, we give the question. Question is a company revenue drop by 15% in the quarter. The CEO want to increase by 20% next quarter. What growth rate is required, needed for the current reduced level? Okay. Now consider 3 different approaches to solve. We can consider 5 approaches and 4. So approach 1 is work through it algebraically. Second is concrete number. Third one is a percentage directly. And after exploring all 3, state which approach is most clear and give the final answer. That's how a simple couple of lines, by adding this line, you are moving towards a more advanced technique where you are simultaneously exploring multiple ways of reasoning. Okay, now ask this question to my LLM. That's how we define it and fire it up. So how does it work? So it definitely use the three ways by first is algebraically concrete numbers and the percentage. So because now it's calculating 3, it will take some more time and just wait for it. Now I got my answer. So approach 1, that is algebraic method. So R is the original revenue. After 15%, revenue become R minus 0.15 R, that is 0.08 of R, that is percentage. And definitely it's going algebraic way. Now it's going with the second approach, the concrete number by R equal to 100 divided by 50%, that is 85, increase by 25%, that is 106.25. Again, the same way, good, pretty nice percentage. Now it's dealing with the number with the percentage. So never even 85% is original. We target is more than 25. That will be 106.25. And final conclusion, it says all three approaches yield the same result. A growth rate is 25% is needed for the current. And final answer, the growth rate is for 25%. So most clear approach is the concrete number. It says the concrete number approach is most clear in the providing the stateful numerical example that is easy and full to understand. So now you got an idea. You have multiple approaches to solve a single problem, and you can find out. Okay, you can even use the majority weighting and all. But when we comes to majority weighting, let's say my LLM is hallucinating in any case, and I'm getting a multiple variation of my answer. How I am going to incorporate that those things or those situations in my prompting way? Is there any way I can handle it? So that's how we have very good technique in place. Is self consistency. So self consistency is nothing. Ask the same question multiple times and get the majority weighting out of it, majority voting out of it. So that's we call the self consistency. So we want the same answer every time. That's the need. Is a more deterministic setting system where the stake is very high. You need higher confidence, and you can do lot of LLM calls because you need multiple LLM calls or maybe 5 calls to get the 5 runs output. So when you don't care about the dollar amount, it's certain limit, and but you want higher reliability and more confidence of the system. So combined, you can even combine COT with the self consistency. But let's first understand the self consistency. Okay, so let's explore the self consistency. So in self consistency, first I will ask the question. Let's say I have this question. This question is a bat and ball cost $1.10 in total. The bat cost is one more than the ball. How much does the ball cost? This is the simple question I have. Now I need the answer in a 5 things. So let's create the answers as a list because I need more. So for I in result and I in range of 5. I don't have result now. I in range of 5. I am running 5 times. And how I'm running it? So I have this, how I'm getting the result. Result I am getting by the ask. And ask I am what I am passing? My question, and plus I can add maybe COT. So let's add the COT step also. I have added the COT. Can we think more around it? Let's now play around some randomness because we already saw without a temperature we can do the stuff. And now let's change the temperature with 0.7. Just get more creative. Now, if by getting this result, I want to extract the last line because the COT will give a lot of steps. So I don't want to append all the output. So let's just result dot strip proceed and then I need to split by the new line, and then I will get the final. Okay, so I got my final line. Now I'll append this thing into my answers dot append the last line. I have appended the last line, and even I can print it. Let's print. So I can say let's print my run because it will go to from 0. So let's say I plus 1, and let's run. Let's see the last line. So what I am getting in the last line. So last line, and let's close it. So we can just print it by this thing. So now let's print. Oh, sorry, my bad. Yeah, now let's print. So now we are implementing COT, but I am just getting the final thing. So it give me run 1, 60, run 2, 60, and then things that different variation final answer 60, run 4, 60, and run 5 is also 60. Yeah, so it ran 5 times, and that's why it's taking sort of a 5x the cost for the one answer. Now we ask the question without asking a you are an expert or something. Now that comes a very interesting part, why we need that sort of setting, and we call it a role. So because there is a one system, and it can behave in a different angles or different perspective or different roles it can play. But if we assign it, so it can consolidate the knowledge in that direction only. So let's say if I say, hey, you are a senior database architect, so it can help me very easily to getting me the lot of good SQL queries. And if I ask, hey, you are a 20-year experience with data science, so explain me the concept of bias and variance, it can think in that direction. So that's why the role is very important to get me in the direction, sort of a making behaving as a, like you are an expert, so it instead of giving a very random or general knowledge, it will talk about in that direction. That's we are assigning the role. So that's why role is very important. Now I will assign a you are an expert data scientist and all this thing, but now go into how we are going to define the role. So if you observe in initially in the LLM, the call that we defined is we mentioned this role, uh, the system here, and that we make as a role as a system. So the role is that we pass as a role as in here. Whenever we get a role as a system, the role is system and the content is the whatever the role I am passing to my this prompt. This is the one line. By adding this to my message, I will assign the role to my the LLM. Now let's understand how I can go the role prompting. So role prompting is very popular because everyone is asking something from the LLM and they just said, "Oh, I want because you are a some data science expert and all these things, so I'll be in that direction." This is the very question let's ask. So, what are the key factor to consider when choosing between Postgres and MongoDB for a new project? Okay, now can I ask this a very generic way? I ask like you are a very generic assistant. I gave system role as a, you are a helpful assistant and ask this question. So what the answer I'm getting? It will give very generic answer without any lot of expertise around it. So let's see how it's giving. I got the answer. So answer is gen- when choosing between PostgreSQL and MongoDB new project, there is several key factors. I can just print it. Let's say instead of just 30 or 300 characters, I can ask instead of 30. Yeah. Okay. It gave me pretty long. A data model, query complexity, transition consistency, scalability, performance development, all these things. Ultimately, guide is specific to project. Now, okay, it gave me too much guide. So I will make it this as an expert. Okay. And I don't want to be the tech. So I ask is that the system as a, you are a senior database architect, 15 years of experience. You have deployed both PostgreSQL and MongoDB to production at a scale. Give practical advice based on the real world trade-off. Note the textbook answer that you give on the top. So now let's fire this question and get an idea. So, okay, I ask this question. Let's get an answer out of it. And how is the answer differ from the previous one? Let's just print it whenever. Okay, I got my answer. Okay, it gave me like this. So it gave me data extraction, schema flexibility, query complexity, scalability and performance, consistency and transaction. So for both things, it's giving the Postgres and development speed and term expertise, ecosystem and tooling, use case specification, cost identification, cost consideration. Initially, it was giving, but not in that direction of going towards the more database side. But here it's giving more implementation knowledge where like or the partitioning, sarding. So how you design the things into both, if you're thinking about the scalability and performance, how the Postgres and SQL MongoDB work. So it's giving more clear answer as I see. Now, okay, uh, I am getting a lot of answer, but in a messy format. So can I think in much better structure way? Let's say I have this text. Can I get some structured output? Because I can't read. If I need to parse it, I need to read line by line and find out. So now the most important part is come. how we are going to get my output as a structured way, in a structured way. So let's explore this part. We already have this proper uh, video in my channel. Uh, you can explore that channel. You can explore this video, but that is more sort of a advance by creating the schema and all. But let's understand by very basic understanding by the prompt. So if you are more keen into getting more advanced thing, you just understand here, and then you can explore the most advanced thing in that video. So, but yeah, let's define this prompting. So for extraction of information, because it's always very tricky when you are extracting information from some data and you are want to pass in this JSON. Extract the following. So this is the example. Extract the followings from the text and well JSON. So there is a text. Sarah Chan, a software engineer at Google, presented a distributed system at ACM conference. Now I want this information like name, role, company, topic, event, location, date. This is the format I'm looking out of it from the text. Okay. Now let's run this thing. So how I'm trying to get the information out of it. So you are a data extraction tool and return an only valid JSON, no other text. So if I fire it up and I will get my some result. So if I got something, I- okay, let's say result, I got this answer and let's just print it. Okay, I got pretty good looking JSON. So now JSON is good, but now the important part is, can I parse it? So let's parse it. Let's JSON dot loads. So can I load this one into my JSON? Let's see result. Okay, I have this parse. So print the parsed one. Okay, I have this pretty well. This is parsable. Now I can parse this my output. Now let's come to our more complex thing is I have something, a sort of a message that I need to classify with the intent and everything. So let's say user query, user issue, and I want to parse it in a structured output. I want to find out what is the issue and what is the brief summary. So let's say I have this customer message and I want to return some JSON output with some variables. Like I have been waiting for 3 weeks for my order. Nobody responded to my L. This is ridiculous. This is the message. Now I want to understand what is my intent, what is my sentiment, what is the urgency, what is the key issue, what is the reaction from this message. And that's how if I have this sort of a JSON, I can extract from, let's say, millions of messages. Like, what is the sentiment of my messages? Like, if I have the customer 100, like, let's say, 1 million of customer messages, what is the number of message I have the positive sentiment, or let's say negative sentiment? So, in these use cases, this is very, very important to parse this thing into a structured way, making into more sort of a structured way in JSON format, or maybe you can dump into DB later and do the query. So, okay, I just make a system as a return only validation, and I'm passing now the response format. Response format is the JSON object I am expecting. I am expecting JSON format. So let's say if I got the output, I will load into my again the JSON and let's see it. Okay, I got it. Intent in the complaint, sentiment is negative, urgency is high, issue is delay in the order fulfillment, and suggestion investigate the order status. Very nicely, I got all the information from my free text to in a structured way. If I someone is looking, okay, what is the number of complaint with the high urgency? I can just fill in the filter and get an out. I can now dump this information with my 5 columns and all this text into my structured DB. Very interesting now. So okay, now we are done with we are now explore all this JSON mode and the this JSON prompting. Now let's understand the chaining. So chaining is something we have some part like we have some multiple prompt and we want to get we have some initial input we extracted something from one LLM call. Now we want to pass this output to my other LLM call, and then that's how we are doing some chaining in different LLM calls. So let's do it. So we have this one article, Apple's internal report. So this is the let's say chaining of LLMs. Let's say LLM calls. Okay, this is the LLM calls chaining. Now, let's say the simple example is we are using one LLM output to into input as the other LLM. So in this one, just do the step one as a extract the fact. So the prompt is extract all numerical facts from the text to build in bullet list. Okay, and what is the system? Extract fact precisely, use bullet points. So let's run it. So it's extracting the fact, and these are the fact. It extracted. Now I want to analyze these facts from my LLM. So instead of passing my initial text, I will pass my, based upon this fact, what are the two strongest and one weakest area. And here is the fact list of facts. Instead of my initial article, I am passing the fact and be specific and the site numbers. Now analyze, it will do the analysis. Sorry, my bad. It's coming. Okay, it's analysis step, and it gave me the iPhone revenue, service revenue, and the weakest area is Mac revenue. Okay, pretty interesting. Now I have this analysis. Can I use the recommend? Can I get a recommendation out of it? So let's run the third step, recommendation. So based upon this analysis, write a 2-sentence investigation recommendation and passing my analysis. Be conscious and specific. State whether to buy, hold, or sell and why. Okay, run it. And now it gives me the buy. The strong performance is iPhone service revenue indicates solid growth potential and resilient market position outweigh the decline in Mac revenue. I got my final recommendation by running the different step instead of just going one step to a second step. So these are the ways of prompting. We explored first the zero sort, few sort, chain of thought, zero sort with chain of thought, then a tree of thought, self-consistency, running multiple times, role prompting, we assign the role and then structured output, and the prompt chaining. So by these sort of 9 techniques, you have an idea of overall how my LLM internally works when we ask some question, how this try to solve the issue. Okay. So now we have basic things, but in this series we mentioned we are building the AI agent. AI agent use this technique, but not fully. They have more extension of this AI, the more prompting. So let's example, these are React. So React is the combination of chain of thought plus tooling. So if I directly jump to the React, then you say, okay, what is chain of thought and what is tooling? So we have the idea of chain of thought now and how we are going to integrate our chain of thought with the tooling. And we have a planning, like chaining with the plan, and we have reflection, like self-checking, and we will then explore the guardrails and role in safety by the prompt. So in the next episode, we will explore the prompting tactics that are very powerful for or very useful for my AI agent. Like we can call it a AI like agent prompt engineering. Okay, so majorly React, planning, reflection, and some bit of guardrails. In the next episode we will explore. Okay, so if you have learned something from this series, and uh, if you are loving this one, just like the episode, share with someone who's keen to learn with the like basic prompting in just couple of minutes. It's not a very long task. You don't need to watch a 2 hour webinar or 2 hour long series episode. So I would say instead of watching all the long uh, lecture or video, 2 or 3 hours video, I would say just code the things by yourself. So now you know how to do the different prompting in a notebook or in a code. So instead of watching how this prompting, just try to implement and see how the things are working. So now after exploring all the techniques, you have an idea which one I need to use in which use cases. So that was the goal of this episode, and hopefully you have learned something. So if you have learned, yeah, keep watching and keep loving this series. Thank you. Bye bye.